How things work. Different energies are used for working of different machines. Energy exists in different forms. In this unit, we learn about electricity and magnetic energy. Magnets. A shepherd by name Magnus used to take sheep to Mount Ida for grazing. One day, he observed that his shoes with nails are attracted by a stone. These stones are called lodestones. That means natural magnets. The name of the magnet is also derived from the name Magnus. The attractive property of magnets is known as magnetism. Things attracted by magnets. Objects like safety pin, alpin, iron nail are attracted by magnet. This property of magnets is known as attractive property. The objects that are attracted by magnets are called magnetic substances. Objects like paper, wood are not attracted by magnets. Objects made of brass and aluminium are also not attracted by magnet. The objects that are not attracted by magnet are called non-magnetic substances. Magnets are in different shapes. The magnet, which is cuboid shape, is called bar magnet. Take some iron fillings and a bar magnet. Roll the bar magnet in the iron fillings. Observe some iron fillings attracted to magnet. Place the magnet with iron fillings on other paper as shown and observe. It is observed that lot of iron fillings are attracted at the edges and less fillings in the middle of the bar magnet. So, it is understood that magnetism is more at the edges of a magnet. The edges of magnet where the magnetism is maximum are known as magnetic poles. Every bar magnet has two poles. Freely suspended hanging bar magnet always denotes north and south directions of earth. This is known as direction property of magnet. Compass needle. A freely moving magnetic indicator placed on pinpoint and arranged in a circular box is called compass needle. The circular box is closed with glass. Indicator in the compass always indicates north and south directions of earth. It is used in ships to find direction. Attraction and repulsion between magnets. Activity. Take two bar magnets. Observe their north and south poles. Arrange them opposite to each other such that north pole of one magnet faces the south pole of other magnet. North pole of a bar magnet facing the south pole of other magnet. Slowly bring them closer. Both poles are attracted to each other. When the second magnet is moving slowly at one point, you observe both of them stick together. Now, place the north poles of two bar magnets facing each other. Slowly push one magnet towards the other. Both the magnets repel each other and move away from each other of like poles. By this, we can observe opposite poles of magnet attract and like poles of magnets repel. This is called magnetic pole property. Magnetic induction. Take a bar magnet, a safety pin and an alpin. Take the magnet near to the safety pin. Safety pin is attracted by the magnet. Leave them like that for a half an hour. Then remove the safety pin from magnet. Now take the safety pin near to the alpin. We see the safety pin attracts the pin. Safety pin gets the characters of a magnet when it is attracted to the magnet for some time. Now the safety pin acts like a magnet and attracts the alpin. Here the magnetism is induced into the safety pin and it acts as a magnet. Magnetism can be induced into substances like iron, steel and nickel. Inducing magnetism into substances is called magnetic induction. Uses of magnets. 1. Freely suspended magnet always indicates north and south directions of Earth. This direction property is used in making compass, which is used in the ships to find directions. Pure stainless steel is not attracted by magnet. This quality of stainless steel can be checked with a magnet while buying. Magnets are used for making speakers of radios, tape recorders, and TV. Place a magnet in the lid of pin box to handle the pins easily. Magnets are used as door stoppers. One magnet is placed on the door and the other on the wall. The door is attracted to wall and doors will not move for the wind. Electric current, electric circuits. Current has an important role in our life. This current is called electricity. In 600 BC, a Greek scientist, Thales, used his woolen coat to clean amber. He observed a strange behavior that amber and woolen coat started attracting pieces of paper and cardboard. Later, in early 16th century, an English doctor, Gilbert, proved that glass rod attracts pieces of paper when it is rubbed with a silk cloth. He named it as electricity. Static electricity. Activity. Comb the dry hair many times and bring the comb near to the pieces of paper. Take a glass slab and rub it with woolen cloth and bring it near to the pieces of paper. Observe what happens. Pieces of paper are attracted by comb and glass slab. This attraction is because of the friction caused due to rubbing each other. The comb and hair, glass slab and woolen cloth. Electric charge formed due to the friction force remains static at that place only. This is called static electricity. Electric charges and kinds. All substances have electric charges. Electric charges are of two kinds, if that positive charge and negative charge. Normally, objects have both the charges equally, so they are neutral. Electric charge is measured in coulombs. Negatively charged electrons flow through the wires like copper and aluminium. This flow of electrons is called electric current. The flow of charged electrons in unit time in 1 second is known as electric current. Q. Coulombs of current passed through a wire in T seconds. The electric current passed in 1 second is Q by T. This is called electric current. Electric current I is equal to Q by T units for current is coulombs per second, is also known as an ampere. Current is measured in amperes. Ampere is equal to coulombs by second. There are electric power stations at Nagarjuna Sagar, Ramagundam and Vijayawada. Power generated in these stations is supplied to different places and electric appliances work with this current. Electric circuit. Activity. Take a torchlight bulb, battery and switch. Connect them by soldering using a copper wire. Take the help of your teacher for soldering. This forms the circuit. Now, observe the electric current flowing in circuit by operating the switch on and off. Observe that the bulb glows on flow of current in the circuit when it is closed by putting the switch on. When the switch is off, the circuit breaks and the bulb is put off. Current flows in the circuit when it is closed. Current does not flow when the circuit is open. Metals like copper, aluminium, iron, etc. allow the flow of current. Substances that allow the flow of current through them are called conductors. Substances like thread, rubber band and wooden piece does not allow the flow of current through them. Substances that does not allow the flow of current through them are called non-conductors. Rubber chappals can be used to avoid the electric shock when rubber gloves are not available. Mechanism of torchlight. Torchlight is used to emit light in the darkness. Batteries, bulb, and switch are the parts of torchlight. There is a hollow cylindrical barrel in torchlight. A lid with screw can be opened and 2 or 3 batteries can be placed in it. Bulb glows when it is switched on with closed lid. When switch is on, the circuit is completed and the current flows through the circuit and the bulb glows.